what the slope is, like by definition? How do we explain what the slope means?
Steepness.
Okay, it's the steepness. And how did we find that? How do we figure out how that line is moving? The way it's going up and also the way it's going down. Okay, so up and down, and then what else? The way it's going. Is it the, well, we could start at the origin if our graph goes through there. So we definitely need to know how it's going up and down, but just straight up, straight down, that's it. And how much it's going over. Good.
So Giovanni, I just heard you say something about triangles. Can you elaborate? What do you mean? What about the triangle?
Oh, I like how he said that.
Yeah. Rise over run. So what can we do? Like, give me an example. What can we do with this line right here? You want to start right here?
What's that called? It's not a dot, it's a what? So that is good call. That is the y-intercept. You could also say it's a point on the line. What else can we call that? A coordinate. Perfect. We want to try to use that math terminology. Good. So you start at that coordinate.
So you're going to go, oh, you're going to run to or rise to? So we're going to rise to, go up to, and run how many? 3.
So let's think about what we just did. You went up 2 units, right? Now, you went over 3 little boxes of that graph, but did you really only move 3? Look at the numbers. Look at the values.
You went over 3 of 6.
You actually went over 6. Do you see the difference between that? Because each box, I'm sorry, go ahead. You were just saying exactly what I was going to say.
Our x-axis is labeled not by 1, 2, 3, 4. Take a look at how it's labeled. It's skip counted by 2. 2, 4, 6. So each box, it is a unit, but it's actually just, it goes by 2s. So it's going over like the 3 times, 3 boxes, but each box counts as 2. So it's actually, like you said, running or moving to the left or right. Okay, so moving to the right, 6. So what is our slope here? We said, Giovanni said we're going to go up 2 and to the right 6. What is our slope?
How do we represent that as a number? Remember, it's our change in y compared to our change in x. And this will be on an anchor chart by tomorrow, because this is like we've already kind of thrown it all together. So Lewis says 6 over 2. We agree?
Why is it 2 over 6?
Mary thinks it's 2 over 6.
It's rise over 1. So it's a change in y, and y goes up and down. Right? And then over the change in x, which goes left and right.
Think about why that is. For every 1 unit of x, how much are we moving how much is our y-axis growing? If I went from an x of 0 to an x of 1, I'm actually moving 1/3 of a unit. So the slope here, you're saying 2 over 6. Our slope, if we simplify, can be 1/3, because for every 1 unit of x, and that's why you're going to put that x value in the denominator, because your x is going to be the 1. For every 1 unit, you're moving up 1/3 of a unit. And we're going to focus a lot on graphing today, so make sure you see, if you're given an equation, which we're going to start to go over, how to actually plot the points and graph that.
So our slope is that was 2 over 6, or if you take a look, we can move up from here. If we want to use that slope, because from here we went 2 over 6. It's the same as going up 1 and over 3. If we started here, we went up 1 and over 3. That's another point on our line. Then we went up 1 and over 3. That's another point on our line. We can find every point on our line by doing that. y-intercept here? What is a y-intercept? In general, what's a y-intercept? Where the line crosses what? Where the line crosses or intercepts the y-axis. Where x equals 0. Because anywhere on the y-axis, x is going to equal 0. So if you like to think about it more like mathematically, it's wherever x equals 0, it's what y equals. It's the y-intercept. Or if you like to look at the graph, it's where the line crosses the y-axis. So where does our line cross the y-axis?
Take a look at the board. Everyone should be able to identify this, which means all of your eyes should be on the board, at least looking where it is.
Where does the line cross the y-axis? And -2 at this point right here. See, x is equal to 0 there. The coordinate for that point is 0, comma, -2. So x is equal to 0, and it's where the line crosses the y-axis. Our line keeps going this way, and it's exactly where it crosses the y-axis and -2. So how can we use this information? We have our slope is 1/3 and our y-intercept is -2. How can we use that information to write an equation? Does anyone remember that little formula that we had on the board yesterday? Y equals mx plus b. What does the m stand for in this? What does the m stand for? The slope. And what is the b? What does the b stand for? Remember, I had you all write it down. We all practiced it. What does the b stand for? The y-intercept. So m is the slope, b is the y-intercept. How can we use this information that we have now to make an equation for this line?
And it may appear like you're just substituting values in right now, but that's exactly what you're doing. Because you did it in reverse. You found the components of the equation, and now you're building the equation. Other times you'll be given an equation, and you'll use those values to create the line. So how can we use those values to substitute in and create our equation?
Did we have to write plus -2? What could we have written instead?
This minus.
We could have just subtracted 2 because adding a negative is the same as subtracting. So our equation for this line, we just wrote an equation for line. Y equals 1/3 x minus 2. So we know that our slope is 1/3 and our y-intercept is at -2. All you're really doing, like Mrs. said, all you're really doing is substituting. The slope is m and the y-intercept is 8. So at this point, when you're making that equation and you have your slope and you have your y-intercept, all you really have to do is substitute it in to y equals mx plus b.
And if you were given that equation, y equals 1/3 x minus 2, if you're being given this from the other way, you can actually create this graph by first, how many points do you need to draw a line? 2. Do I know any points on that line just by looking at the equation? Which point on the line do I know just by looking at the equation? Remember, I know, and what is -2? Where do I put it? Who can help explain it? Because he's on the right track, just getting those words out. We see this part, okay? Because now what you're doing is we took the graph and made it the equation, but a lot of the times you're going to take the equation and plot it. What point do I know? Raimundo said we know -2. What does that mean? Where do I put it? What is that? On the y-axis. So I can go here, and now I know this point. It's the y-intercept.
Sorry for the interruption. Just want to let all of our students know the administration just did an electronic search inside each classrooms within the school. We picked random ones. Some electronics were confiscated. So once again, to our students and teachers, please remind your students that you are not allowed to have your wires draped around your body or using electronics inside the classroom unless instructed by a teacher. Once again, students, your electronics will be confiscated. There will be consequences if you are not listening to this simple rule. All electronics must be inside your pockets at all days unless a teacher or administrator tells you differently. Thank you again for your cooperation, and everyone have a great day.
So we have 1 point now, and we used our y-intercept. Now, what other part of the equation can I use to get another point? How can I use the 1/3, knowing I only have this 1 point? How can I use the 1/3 or the slope? So now from here, I can go up 1 and over 3. And there's my point. I can even do it again. Up 1 over 3. So I have 3 points, and then I can draw my line. And I've used that. So that's how you can go from the graph to the equation, and then from the equation back to the graph. Especially when it's in that format, they're already giving you one of the points, and then you can use the slope to find the next point. Then you're done.
I know some people were a little confused yesterday with this. The slope is not a point on your line. The slope is how you're moving from point to point on your line. Okay? Some people got a little confused by it. Okay? Now let's take a look at this table. And how can we find the slope of the line using this table? So these are our x's and these are our y's. What can we do with this table to find the slope?
Divide the y and
Not just divide. We want to
Well,
find
subtract.
what's the slope? It's the slope.
Remember, like when you said before the definition of the slope, Jarek, what did you say? It's the steepness. Okay, and also we were finding how our line was moving. Using the table, how can we figure out how our line is moving? What in the table shows us that it is moving?
Think about the different ways that we learned how to find the slope. Like Leslie, I know you said you loved a certain way to find the slope. You were like, oh, this way is so much easier the other day.
Which way was that?
Think about the different ways we learned how to find the slope. Subtract what? What do you want to subtract? You want to subtract what? I just couldn't hear you. Say again. You want to subtract? Like, give me an example from here. What do you want to subtract?
How is our y value moving? From one coordinate to the next, how's our y value moving? Jared?
getting smaller
How much smaller?
by 4.
How do you know it's getting smaller by 4?
It starts at 5 and goes.
All right, so our first coordinate, if you look there, has a y value of 5. So you can imagine in your mind where that would fall on the graph. Okay? And then the next coordinate on our line has a y value of 1. So it just did what?
Subtract.
So it subtracted, or what direction did it move? If you're thinking about a line.
Down.
It went down, how many units?
4.
4 units. So we just found the change in y. Y went from 5 to 1. It went down 4, or negative 4. Now, how about the x value? Raimundo.
It goes up to 3.
It's increasing by 3. We have our first coordinate had an x value of negative 3, and then now our next coordinate has an x value of 0. So it increased by 3. How do we show an increase of 3 with our x value? How does it move if we're increasing our x value 3? Does it go up, down, left, or right?
Up.
For our x value,
Down.
Oh no.
Both sides.
it would be an increase. It would be a movement to the right. So we just did our change in y compared to our change in x. So how can you put that together and represent your slope? How do we show change in y over the change in x. We just found the numbers because we found the movement. How do we put it together into one slope? Use the numbers that we put on the board and put them together.
Positive 3 out of -1.
Think about how we represent it. Which one do we change?
Change in y over the change in x.
The 4 goes on top.
Okay, so what would our slope be? Put it all together.
-4 out of positive 3.
Negative 4/3, which means I'm going to go down 4 units and to the right 3 units. For every 1 unit of x, I'm actually decreasing my y value by 4/3. Is that line going to go up or down? Say it again.
Down.
How do I know? Who else can tell me? How do we know this line's going down without even graphing it? How do we know? Somebody else. How do we know that this line is going to go down instead of rising up?
Because it's a negative. Because our slope is negative. Okay. So because our slope is negative, we know that our line is going to go down. It's going to go down, okay? So now we found out our slope. We just found it out. What was it? What was our slope? -4/3. How can we use this information to graph the data? What else do we need? Is there anything else we need besides just the slope? The y-intercept, or can we use this like any of our points?
How many points do you need to create a line? So can I just use any coordinates on that table? Would it give me a line?
Let's
Well-
try it out.
Are all of those coordinates on the same line? If I plotted 2 of those coordinates, any 2, and I just drew a straight line between them and extended that line both directions, is that going to be my line? Would every other point on the table fall on that line? No. Let's see if it works. Let's try it.
Let's plot these points. Where did I plot them? -3. -3, 5. That's our first coordinate. Okay. Next coordinate. 0, 1. Alright, our next coordinate. 3. Oh.
Those must be positive.
Oh, positive. Alright, and then 3, 3. Does this look like a line?
Yes.
Does it look like all these points are on the same line? No, my lines aren't straight, sorry.
What does it mean for coordinates to be on a line? I know it's like a weird question, but this is kind of how it all gets put together. So let's look really quick at this. What's the value of x? 3. How do you know? And you could solve it, right? You could, and then if I think it's 3, what would I do? I could substitute a value in. And how do I know after I substitute that 3 is the answer? So what do I know about both sides? In order for a solution to be a solution, both sides of the equation need to be equal. So it makes it a true statement. So let's look at something like this. So I think the coordinate 0, 2 is on this line. And I also think that 1, 4. So I'm writing coordinates. And I know for a fact that these points are on this line. And I want you to figure out how I know that while I'm writing them. How do I know that all these points are on the line? Hey, how do I know that these are on the line?
Yeah, we have a new student.
Okay,
Just came
great.
in central registration this morning.
Oh, great. Come on in.
And, Jared, come here really quick. This is your teacher, Miss Caravano.
Hi, this is Miss K. So while we get situated here, how do we know? So this equation here is y equals 2x plus 2. Everybody pay attention here. How do we know? Ooh, you can come right here, sweetie. How do we know that if this is our equation, these are points on the line? Think about what we did to prove that 3 was an answer here. How do we know that these work? Think about what they mean. Here are my coordinates. 0, 2, 1, 4, 2, 6, 3, 8, 4, 10. How do you know? How do I prove that? All the numbers are what?
All the numbers are getting out of that. Well, except
How do we know? Again, use what we did with the first equation. Marco said he thought that 3 was the answer, so we substituted in a 3 for x because he said x equals 3. So we substituted in and got a true statement on both sides. Right? How do we know for sure that an x value of 1 and a y value of 4 makes or is on that line? How do we know? What did we do over there that we can do here?
choose that.
To what? Okay, so if we think an x is a 1, all right, so x is 1, what's y? What do we think it is? X is 1, y is 4. Okay, so let's see, is that true? If I substitute that, and then 2 times 1 plus 2. Is that true? It is, right? Because 2 plus 2 is 4. So how do I know that all of these points are on that line? Because what happens if I replace the x and the y in the equation? What do I know about the equation? It's still going to be, it's going to be the same on both sides. So let's see this, let's do this coordinate, 0, 5. Is that a point on that line? How do you know it's not? What do you mean?
I was just going in order, like 2, 4, 6.
Well, let's not even talk about the order. What can I do to prove that that point is not on that line? How do you know? Think about what we did with the first. Marco said x is 3. So we're like, all right, well, let's take a 3, put it in for x. I'm saying that here x is 0 and y is 5. How can you prove that it's not on the line? All right, if I substitute in a 0 here, it'd be 2 times 0 plus 2 equals 5, right? Because I said x is 0, y is 5. So let's see, 5 equals 0 plus 2. How do I know that that point's not on the line? Because that statement's not true. We spend a lot of time graphing lines, but the connection is, if the point is on the line, that means those coordinates, that x value and y value, satisfy the equation. It just so happens there's a lot of points, and really every decimal in between that you see on that graph is a solution for that equation. And I know we look at this and we think it's a line. It's still an equation. It just has 2 variables. So if you ever need to prove if something's on the line, substitute the values in. But everything that's on that line is a solution. So we're finding all of them.
So we just graphed all these coordinates onto this graph.
direction.
It's moving down.
Down. Okay. But if we started out like this point, let's say we want to start at -3, 5. How are we moving to get to the next point on our line? How can we move?
The bottom one is going down and the top X is going down and no. X is going up and Y is going down. Like value increasing.
Oh, okay, like the value. Okay, so, but how is the line actually moving? Like, in which direction are we going? Think about what the slope means. The slope is -4/3. How are we getting to like our next point? What are we doing to get to our next point? How can we get to our next point using this slope? What does like the -4 mean? What does the -4 mean? What is the slope? We said it was the change in y over change in x. What does that mean? That's the change in y over the change in x. What does that mean? What does that mean? Change in y with the change in x. How are we moving? How does, when y changes, how does it move? It moves like up or down. Good. When x changes, how does it move? It moves like left or right. So we know that our slope is the change in y over change in x, and we know it's -4/3. How are we moving?
We're moving down and then we're moving right.
Okay, so we're moving down how many? How many are we moving down?
4.
We're going to move down 4. So if we start at this point right here, we can move down 4, and then where?
3. To
And then to the right 3. And that will give us our next point. That's what the slope is, how our line's moving. We're going to move down 4 and over 3. Down 4 and over 3. And that's going to be every point on our line. And what? It's pretty much like a unit rate.
Now we know our slope. We learned that our slope is our unit rate because for every value of 1x, what's our y value? -4/3.
Alright. So in your group, I want you to write an equation for this table and this graph. Okay, so you can use your whiteboards. I want you to take this table and this graph, and I want you to write an equation, and I want you to figure out, like, verify that it works. Yeah. So you're working with them, and I want you to make sure, show each other how you know that is the one whiteboard.
Okay, we want to okay, what color? It's in our hand. Green.
His name is that's gonna close off and what am I gonna do? And then I was like, come on, I'm running out of time. And I was so confused. I have this
Yeah, that is the same place.
Yeah.
We went through
Yes, we never did.
So what 2 things do we need to write the equation?
We need to write the equation. So equation is on the board.
values we need are the.
What was the M is?
I was thinking that the slope.
I heard somebody say it.
Yeah.
It's not. It's the drive. It's the drive.
Yeah.
Oh, there's not. They sold.
And then I need you to verify that the equation you wrote works. So just like Mrs. Ibu showed us on the board, how did we verify that that's what we worked? How did we check that?
Wait, is that in order?
Oh.
This is actually your definition. I'm not checking it. So after you have your equation, you're going to check that it works. Think about how you check that it works. You just did it with a different equation on the board over there. Right now. Somebody have to
Giovanni is the y-intercept.
I use 34.
The y-intercept.
It's where the Y.
No, wait, 5 over X.
It's not moving right now.
I didn't think that.
So this is about Y.
Miss,
The
is it with
equation.
those symbols?
And this value represents.
Stop.
Okay, everybody bring it to the front now. Bring it to the front, we're gonna go over this. Like everybody.
Oh, I thought you had like
Try it down. What? What did we get? Y equals 4.
None of these songs.
Okay, somebody tell me. Quiet down. Somebody tell me. How Giovanni got negative 4/3 x plus 1. Y equals negative 4/3 x plus 1. And how did we get that?
The videos. Watch them on YouTube.
3 over 3.
Okay, so Marco's saying that he moved down negative 4 and over 3. So what is that, Colin? That's the slope. So M is our slope. So we found earlier that our slope was negative 4/3. So all we had to do was take the negative 4/3 and kind of plug it in for M. Right? We just had to substitute it for M. So how did we get the 1? How do you think we got the 1? Right. How do you think we got the 1? Like, where did that 1 come from? The y-intercept. Our B is our y-intercept. So all we have to do is plug in the slope and the y-intercept into this equation to give us our equation for this line. What is a y-intercept? Where our line intersects the y-axis, where it crosses over the y-axis. So at what point does our line cross over the y-axis?
0.1.
both y. Okay, so at 0, 1, where x is 0 and y is 1, that's where our line is crossing the y-axis. So our y-intercept is just 1. So that's why we added 1 here, because our formula here that we're plugging into tells us add b, or add the y-intercept. So that's how we got y equals negative 4/3 x plus 1. So using this equation, we could graph this line. How can we do that? Using this equation, how can we graph this line? I know we already have a graph. So what can we do first?
You can graph the 1 first.
We could graph the 1. That is a point on our line. The 1 is a point on our line. So you can take that 1 and know that where 1 is on the y-axis is where it's the first point, is a point on our line. Right there.
And then you go down
And then from there you can go down 4
3.
and then over 3, and that gives us another point on our line. Okay, so the slope is not a point on your line. The y-intercept is a point on the line, and from there you can move to find the next point. And how many points do you need to draw a line? 2. 2 or more. So,
And to find the top one, the opposite.
oh, that's Martha has a really good point. If you wanted to find a point, if you wanted to find a point that was like up here, how are we moving from our y-intercept to get to this point? How are we moving to get to that point? We moved down 4 and over 3 to get to this point. Well, how are we moving to get to this point? How are we moving to get to this point from here to here? What are we doing? The opposite, meaning, like, tell me. From here we're going to the left 3 and then up 4. Is that the same thing? Like if I move right now, I'm gonna move to the left 3 and then I'm gonna move up 4. And then our slope was down 4 and to the right 3. Did I just do the same exact motions?
Yeah.
Yeah.
Just back.
Yeah, but like backwards first,
So
right?
it's negative 3 over 4. Yes. No. It is? Yeah, because you're
So
it's
what
negative
we
4.
what we did to get from here to here was we actually did 4 over negative 3. We actually moved up 4 and to the left 3. Is that the same thing?
Yeah.
Is negative 4 over 3 the same as 4 over negative 3?
But I had it backwards. Yep.
Yeah, that's the same exact value. So in this case, we're moving down 4 and to the right 3. But in this case, we're moving up 4 and to the left 3. Do we all see how that's the same value?
Yeah.
Okay, so our DOL today is write an equation for this graph. So think about the form that you need to write an equation. Yeah, think about that. And think about the 2 things that you need to plug into that form. Okay? And I want you to all, for your DOL, write an equation for this graph. We're not discussing it, we're not working together. Okay? You can write it on the paper from yesterday. So we're not talking right now because we're all working together we're all working alone we're all working alone on our DOL. Okay?
Can you stop the video?
Look at kid. Yes, I read my DOL.
Oh, she was recording. What?
My DOL from yesterday.
1 second.